Hi everyone, so today we'll be looking at multiple choice CSEC past paper questions on circle geometry. Now, for each question that I have here, and on the right hand side, I have the rules that we use in circle geometry, so we can easily refer to them in each case, right? Now, I'm just going to run through the rules quickly and then we will start with the actual questions. So the first rule we have here is the angle at the center is twice the angle at the circumference. So the angle at the center is 2 times the angle at the circumference. So basically, if I have the angle at the circumference, let's say it's 70, the angle at the center will be 2 times that, 2 times 70, which is 140 degrees. And the reverse, if I have the angle at the center, let's say it's 200 degrees, the angle at the circumference will be half of that, which will be 100 degrees. The next rule, angles in the same segment are equal. The word segment was misspelled here, so please ignore that. So if I try to draw a line here, right here, from this point to the bottom here to the other point here, this whole piece at the top here, all here is a segment. This is the major segment, and the underneath will actually be the minor segment. So the two angles in the same segment are equal to each other. In this case, it's A and A, right? Next rule, the angle in a semicircle is 90 degrees. So that semicircle that they're talking about must be formed by a diameter. Once that diameter forms a triangle, it always forms a right angle triangle, right? So it must be that diameter we're looking out for. Next rule, opposite angles in a cyclic quadrilateral add up to 180 degrees. Now, a cyclic quadrilateral is really and truly a quadrilateral, a four-sided shape inside of a circle. Now, what makes it a cyclic quadrilateral? Each point of that quadrilateral must touch the circle. So you see how each point touches the circle? Now, the rule actually says that opposite angles add up to 180 degrees. So in this case, A is opposite to B, so A plus B is equal to 180 degrees. And then we have C and D are opposite to each other, so C plus D, when you add them, C plus D is equal to 180 degrees. Now the other rule here, the perpendicular from the center of the chord bisects the chord. So here we have a chord, this line here is a chord. And once we have a line coming from the center, and it cuts that chord, it bisects it, meaning it cuts the chord in two equal pieces, right? That's what those two lines there mean, right? And the next rule, the angle between a tangent and a radius is 90 degrees. Whenever you have a tangent, remember a tangent is a straight line that touches the circle at one point. So whenever you have a tangent and a radius meeting, they always meet at a 90-degree angle, right? That's what you need to remember. Radius and a tangent, once they meet at a 90 degrees. And then we have the other rule here, tangents from a point outside a circle are equal in length. So you see we have two tangents here. Once they meet at that point there, basically this rule says that these two tangents are equal to each other. So remember those two lines here, those two small little cuts mean that they're equal to each other, right? And then the last rule, alternate segment theorem. So remember I spoke about the segment just now. So you see from this line here, this chord here, and this little piece underneath here with this from the circle, that's the minor segment. And there's this rest here, all here is the major segment. So B, angle B is equal to the angle in the alternate segment. So the B is actually within this segment, right? So the alternate segment will be up here, right? So those two angles are equal. Same goes with the opposite way, the A. This angle here, this segment, angle here is equal to the angle in the opposite segment here, right? So those are the rules you need to remember, right? Now looking at the first question we have here. If O is the center of the circle, then y degrees is, now y degrees is at the center of the circle, right? And then we are given an angle at the circumference. That actually is our first rule. Angle at the center is twice the angles at the circumference. So now what that says is y will be 2 times the angle at the circumference, which is 2 times 50. And that will really be 100 degrees. So my answer is D. So you see how easy this one is? Now, this rule is actually the easiest rule to remember. Angle at the center is twice the angle at the circumference, right? So the easiest rule to remember. And so this is the easiest circle geometry question you get in a multiple choice paper, right? So now we're looking at this question here. So now the question says, in the diagram above, O is the center of the circle and AC is equal to BC. So O is the center, AC is equal to BC. So you see that the two lines here showing that those two lines are equal to each other. Angle AOB is equal to 140. We want to find angle OBC. So let's just highlight what we want to find. Angle OBC. So actually just this we want to find here. Right? Now, let's look at the information we are given, right? Let's look at the diagram and everything. Now, so in my diagram, you see I have those two lines are equal to each other. If I look at ACB, what shape does that form? ACB. That's actually what? Isosceles triangle. So let's draw the isosceles triangle here, right? Just to keep that in mind, right? We have isosceles triangle. Alright, so now let's look at what else we have. And we know it's isosceles. Why? Because two isosceles has two equal sides, right? Good. And we're given angle AOB. AOB is 140. Now, looking at our first rule, angle at the center is twice the angle at the circumference. So really and truly, what is the angle at the circumference? We are given the angle at the center, so now we have to divide to get the angle at the circumference, right? So 140 divided by 2, which is 70, right? 70 degrees. Right, so that's 70 up there, 70 degrees. Now, again, I want to find, as just this little piece here, I want to find, I don't want to find all of this. I want to find this little piece here. But let's see how we're going to go about finding everything, right? Now, let's look at the smaller triangle here now. Right? OAB. Now, my diagrams won't be perfect, right? Now, why did I put two lines here? I'm basically saying it's isosceles as well. It is an isosceles, but how do I know it's an isosceles? Now, OA is a radius, right? And then OB is also a radius. So obviously, those two sides are equal to each other, hence making it an isosceles triangle, right? So now, this angle here is 140, right? Now, remember the isosceles triangle, two sides are equal and the two angles are also equal. So now to find my two bottom angles, what am I going to do? Basically, I'm going to say 180, take away that 140, which will give me 40 degrees, right? And now to find my two bottom angles will be 40 divided by 2, which is 20 degrees. So I can write that in here. 20, and this as well is 20. Cool. Now remember, for circle geometry, you need to know your basic geometry rules, different rules with angles and with triangles and those kind of things, right? Right. So now we have that 20 and 20 here. Again, we want to find this little piece up top here. Now we don't not forgetting we have the big triangles actually isosceles as well. This was what, 70. If I do the same procedure, I can find this angle and I can find this angle. Let's just box this off. So now let's say 180, take away 70, and I'll get 110, right? And now I have to find the two angles. Remember, the two angles at the bottom are equal. So now we're going to say 110 divided by 2. When we divide that by 2, right, we're going to get what? 55. 2 into 2, 1. 2 into 11 is 5. Remainder 1. And then we get 2 into 10, 5, right? Cool. So now we have that as 55, right? Now, let's try and think a little bit. What else am I going to do? Or what else can I do to find my my little piece? Now, essentially, this big piece here and this big piece here is what we just found, 55. So really and truly, what we need to do to find our little piece, we just need to say our 55. So to find angle OBC would be 55, the big angle, take away 20, which is 35 degrees. And our answer is B. Now I know it's a lot to take in, right? But just stop and replay. Go ahead and do that. But just let me go through it quickly again, right? We were given, they told us these two sides are equal, AC and BC, right? So first thing I said is, okay, this big triangle, because it tells us those two sides are equal, it's an isosceles triangle, right? So I drew that here. Now then we are given the angle 140 degrees at the center. So we know how to find the angle at the circumference, divide by 2, so this is 70. So here we have that, 70 degrees, right? Cool. And you could have gone and worked out these two angles at the bottom here if you wanted. One time, it doesn't matter which one you work out first. So I can do this one time. The 180 degrees, take away the 70 is 110. We want to find, miss two equal angles, right? So you have to divide by 2. And we get 55. So each one is 55. Each of this big angle here is 55, right? And this big thing here is 55. Now the smaller triangle AOB, right? I drew that here. The top was 140. Same procedure. Since isosceles, the two bottom angles are equal, right? So 180 take away 40, then we have to divide by 2. So each one in the bottom are 20 degrees, right? Now, so this little piece here was 20, this little piece here is 20, and that little piece here is 20. Now to find what we want, OBC, which is just this little tiny piece here, right? Is really this big angle, take away the 20 to get the little piece here. So the big angle was the 55, and then we take away the 20, and then we got 35 degrees. Again, if you need to stop, replay, go over it, right?